Okay, can you see my screen? Boleh nampak screen Miss tak?
Boleh.
Boleh ya? Okay. So bear with me. Actually my laptop is not in a good condition, so I'm using different laptop. So kalau korang nampak Miss macam struggle tu, faham-faham ya? Okay, kejap ya. Did I just press the close button? Okay, so today we are going, nampak tak screen Miss? Kenapa dia tak? Dia hilang ni?
Tak nampak.
Tak nampak. Okay, here we go. Okay, so kita akan belajar chapter baru iaitu gravitation. Okay, now can you see my screen?
Yes.
Okay, so this is a new chapter, gravitation. Alright, our first part of gravitation is we are going to learn about gravitational force and also field strength. And the first learning outcome is state and use. Okay, so kita kena state and use the Newton's law of gravitation. Okay, actually bila kita cakap pasal Newton law of gravitation, one thing that yang korang kena tahu adalah dia always attractive. Okay, always attractive. Okay, always attractive. Excuse my handwriting. Okay, now, so what is Newton's law of gravitation? Okay, Newton's law of gravitation adalah magnitude. Okay, dia adalah magnitude of an attractive force between 2 point masses. Okay, I'll explain in detail. You guys don't have to worry. 2 point masses, which is directly proportional. Okay, this is the keywords. Keywords dia adalah directly proportional to the product of their masses. Okay, dia directly proportional tu apa? Kepada product of their masses. Alright, and dia akan inversely proportional. Okay, dan another part adalah dia akan inversely proportional to the square of the distance between them. Okay, so actually apa yang soalan ini cuba sampaikan adalah the statement is, okay, now you have 2 point masses. Okay, kita draw lah, kita draw 2 point masses. Okay, so first and then this is the second one. So 2 point masses. Okay, contohnya this is the first one and this is the second one. This is the 2 point masses. Okay, dia cakap the magnitude of an attractive force. Okay, the magnitude of an attractive force adalah your gravitational force. Okay, nampak tak the first sentence, the magnitude of an attractive force between 2 point masses. Okay, it is the gravitational force between 2 point masses. Is directly proportional. Okay, kita tahu directly proportional. Directly proportional to what? Directly proportional to the product of their masses. Maksudnya product of the 2 point mass. Maksudnya M1 darab juga dengan M2. Sebab produk ini adalah hasil darab. Dia adalah hasil darab. And inversely proportional to the square of the distance between them. Okay, now we have 2 point masses. Okay, 2 point masses ini dia akan ada distance. So distance dia dikenali sebagai R. So first part, the attractive force. The attractive force is the gravitational force is directly proportional to the 2 point masses iaitu M1 darab dengan M2. To the product of their masses lah. And also inversely proportional to, inversely proportional to the square distance between them. So 1 over R squared. Dia adalah inversely proportional to the square of the distance between them. So macam Miss cakap, dia adalah attractive force. So attractive force ini adalah dia punya gravitational force. So maksudnya dia akan ada attractive force. Contohnya attractive force by particle 1 on particle 2 ataupun by particle 2 on particle 1. So ini yang Miss highlight dengan kuning ini adalah attractive force. They always attract. Selalu always attractive. Okay. So therefore kalau Miss masukkan ini dalam satu equation, kita akan dapat equation ini. So we will get gravitational force is directly proportional to the masses of the 2-point mass bahagi dengan R squared. Okay, or we can write it this way. Is my mic wheezing? Kenapa Miss rasa macam wheezing Guys, okay ke?
Okay.
Alright, okay. So, ini adalah hasil darab. But, this equation, dia masih proportional. Maksudnya dia ada directly proportional and also inversely proportional. So, disebabkan dia ada itu, Miss akan tambah constant. I will add constant. So, constant means adalah Fg, gravitational force, equals to gravitational constants darab dengan the first mass darab dengan the second mass bahagi dengan R squared. Okay, mass of particle 1 bahagi dengan mass of particle 2 divided dengan R squared. Okay. Alright, now so far so good. Can you understand what is Newton's law of gravitation? Boleh faham ke? Yang Miss explain ni?
Boleh.
Boleh.
Boleh. Yang lain? Okay. Now my question is, okay, this is my question for you. Unit dia apa? Apakah unit untuk gravitational force? Anyone? Apa unit untuk gravitational force?
Newton.
Newton. Very good. It is Newton. Okay. Now, so korang boleh tulis sambil tu Miss akan buat labeling lah. So, Fg is gravitational force. Gravitational force. M and also M, big capital M and small m adalah masses of particle 1 and particle 2. Of particle 1 and particle 2. So kita ada 2-point masses kan? Alright, what about G? G adalah universal gravitational constant. Okay, so G is universal gravitational constant. Oh. Gravitational universal constant. Okay, so for gravitational universal constant, dia punya nilai magnitude dia adalah sama. Maksud means dia adalah sama as in 6.67 times 10 to power of negative 11 and kg negative 2 m squared. Ataupun awak tulis dulu m squared will be better. Okay, tulis dulu m squared kg power of negative 2. So unit dia, dia punya nilai adalah always constant, sama sahaja. So this is dia punya nilai. 6.67 times 10 to power of negative 11. Okay, what about R? R adalah distance, bukan radius ya. R adalah distance. This is very, very important. And dia adalah radius, distance. So R is distance R is distance between two masses, okay? Distance between two masses. So maksudnya distance between two particles tu lah. So mass of particle 1 and also mass of particle 2. Okay, now my question. Lagi Miss bagi masa salin ya. Miss bagi masa salin. For example, if my products of masses increases. Okay, contohnya dia increases. So what happened to your gravitational force? Increase or decrease?
Increase.
Increase, very good. Okay, now, what if your distance between two particles increase? What happened to your gravitational force? Decrease.
Decrease.
Very good. So and vice versa lah. So kalau dia punya distance, oh kenapa dia tak jadi ni? Okay, kalau ni increase, ini decrease. So kalau lagi satu, kalau ini decrease, ini akan increase. Sebab apa? Sebab dia inversely proportional. Yang ini kalau decrease, ini pun akan decrease. Okay, now I give you few minutes to copy. Not few minutes lah, Miss bagi dalam masa 2 minit untuk copy balik. Okay, now do you have any question ataupun okay? Guys, do you have any question? Okay, alright.
Okay, Miss.
Alright. Sorry ya, my handwriting quite bad because this is the first time Miss pakai drawing tablet. Usually I'm using laptop kan. Please bear with me guys. Alright, let me call one by one. Alif, okay Alif?
Okay, Miss.
Alif, are you okay? Ainur Nazira? Ainur? Oh, okay Miss. Alright, Balkis Batrisha? Batrisha Balkis?
Okay, Miss.
Batrisha Umaira? Chu Sinje?
Okay, Miss.
Hawa?
Okay, Miss.
Izati? Oh, cepat dia. Kalai?
Okay, Miss.
Kenny?
Okay, Miss.
Mawada? Hidayat? Hana Aida? Sorry, line is line problem. No problem. Okay, no problem. Okay, if korang faham and I can proceed, tekan nombor 1 di chat box here. Okay. Okay, now guys, may I proceed? Miss proceed ya? Semua dah habis salin kan? Okay, Miss proceed. Okay, now sekarang awak cuba tengok. Now you have 2-point masses. Okay, maksud 2-point masses adalah kalau awak tengok ini, ini. This is the 2-point masses 1 and this is 2. So maksudnya you ada 2 objects lah, senang cerita. Or we call it as 2 particles. So these 2 particles dia akan ada Newton law of gravitation ataupun kita cakap dia akan ada gravitational force because it always attractive. They are attracted towards each other. Maksudnya sekarang awak akan ada gravitational force by particle 1 on particle 2. Sebab ini kan mass 1 kan, so dia particle 1. So ini kan mass 2, so dia particle 2. So awak akan ada gravitational force by particle 1 on particle 2. By particle 1 terhadap particle kedua. Sama juga you will have attractive force, gravitational force by particle 2 on particle 1. Okay, so it is the same thing. So kalau awak perasan, tengok ni, gravitational force 2 on 1 is equals to 1 on 2. So kita pakai formula yang sama. Cuma dekat sini dia ada pembetulan sikit tau. Sepatutnya gravitational force by particle 1 on particle 2. Sama juga yang ini pun. Gravitational force by particle 2 on particle 1. Okay, boleh? Alright, this one is nothing much. Ini sahaja. Awak cuma kena tahulah dia adalah force dari siapa kepada siapa. Dia attractive kan? Dia attractive. So dia attract kepada siapa? Contohnya macam mass 1 ni. Mass 1 ini dia akan attract kepada mass 2. Alright, okay, boleh? Kids, are you guys okay?
Okay.
Okay, so may I proceed?
Yes, Miss.
Okay, I proceed ya. Okay, now I'll give you few minutes to try example 1. Okay, can you try example 1? And once you are done, tekan nombor 1 di chat box here. Okay, maksud separation is distance, okay? Maksud separation adalah jarak. Jarak ataupun kita kata dia adalah distance. Jarak or distance. Okay, once you guys are done, tekan nombor 1 di chat box ya. Okay, lo are done. Okay. Okay, kalau siapa yang done example 1, boleh try example 2, okay? Okay, banyak done. Okay guys, let's discuss. Okay, dia cakap what must the separation between a 5.2 kg particle and 2.5 kg particle for the gravitational attraction to have a magnitude of 2.3 times 10 to the power of negative 12 Newton. So when we are talking about gravitational attraction, dia adalah apa sebenarnya? What is gravitational attraction? Anyone? Kids?
Force G.
Very good. Dia adalah gravitational force. Okay, sekarang dia dah bagi tahu magnitude of your gravitational force is is 2.3 times 10 to power of negative 12 Newton. Now, you nak cari jarak and distance dia. You sebenarnya nak cari dia punya R. Okay, kita nak pakai formula apa? Anyone? Macam kita nak cari? Kita nak pakai formula apa? Girls? Okay, lu nak jawab boleh lah lo. Okay. Gravitational force equals to
G times mm
mm
square.
over r squared. And then the gravitational attraction, kita tahu dia adalah gravitational force. Dia ada magnitude of 2.3 times 10 to power of negative 12. Okay, now the gravitational constant macam Miss cakap diberi. Okay, gravitational constant is always constant. That is 6.67 times 10 to power of negative 11. And the first mass is 5.2 and the second mass is 2.4 divided by r squared. Kita nak cari r. Therefore, your distance is 19.02 meter. Okay, boleh?
Boleh, Miss.
Boleh ya? Alright. Okay, boleh Miss proceed? Semua orang dapat? Korang boleh semak ya jawapan korang?
Dapat.
Dapat. Okay, now kita proceed. So now is example 2. Dia cakap apa? During a solar eclipse, the moon, earth and sun all lie on the same line with the moon between earth and the sun. Okay, maksudnya sekarang awak akan ada moon. Okay, so moon awak dekat sini. Okay, and then you will have your earth and sun. Sebab apa? Sebab dia cakap moon, earth and sun semua berada dekat atas line yang sama. Cuma moon is between your earth and sun. Okay, kita draw dulu sun. So this is your sun. Okay, so this is your sun. And then this is your moon. Earth. Okay, Earth. Okay, draw dulu. Okay, after you done with your drawing, awak tengok pula what is the next question. Dia cakap apa? Dia minta apa? Okay, dia minta how much force is exerted by the sun on the moon. Jadi dia minta gravitational force by the sun on the moon. Jadi dekat sinilah kita nak cari F sun on the moon. Okay, contohnya Miss buat 3, 2. So kat sini Miss jadikan ini adalah the first particle, the second particle and the third particle. Okay, actually kita nak cari force exerted by the sun on the moon. Okay, now let's look at the information given. Okay, the information given is mass of the sun, mass of the earth and mass of the moon. And dia cakap sun-earth distance. Okay, mari kita tengok ya, sun-earth distance. Sun-earth distance is berapa? Dia adalah 1.5 times 10 to power of 11 meter. So this is your sun, moon and earth. Okay? And then dia cakap earth-moon distance is 3.84 times 10 to power of 8. So this is 3.84 times 10 to power of 8 meter. Okay, what about the distance from moon to sun? Okay, siapa tahu how to calculate the distance from moon to sun?
Jarak sun tu Earth tu tolak dengan Earth to moon.
Very good. So, awak akan ambil jarak earth to sun tolak dengan jarak earth to moon. Okay, cuba tekan kalkulator. Bila korang tolak, korang dapat berapa? Okay, korang dapat berapa bila korang tolak? Anyone?
1.496 darab 10 kuasa 11.
Jarak 10 kuasa 11. Very good. So, dia adalah 1.496 times 10 to power of 11 meter. Okay, now we are looking for the gravitational force exerted by the sun on the moon. Okay, so kita carilah gravitational force dia. And kita tahu formula gravitational force adalah G darab dengan mass of sun darab dengan mass of moon bahagi dengan R squared. So kita tahu G will always be constant. G korang always constant, which is 6.67 times 10 to power of negative 11. Darab dengan mass of the sun and mass of the moon. Okay, cuba tengok mass of the sun berapa? Mass of the sun is 2 times 10 to power of 30 and mass of the moon is 7.4 times 10 to power of 22. Okay, dan bahagi dengan distance from the sun to the moon. And distance dia adalah 1.496 times 10 to power of 11 meter. So, tekan calculator, you will get berapa? Okay, cuba tekan. Okay, ini ada square ya. Okay, cuba tekan calculator. Korang dapat berapa? Okay, how much do you get? Anyone?
4.41 times 10 to the power of 20 meter.
4.41 times 10 to power of 20 meter. What is the unit? Meter? Meter ke unit dia?
Newton.
Newton. Nak kena dengan Miss. Okay, boleh? Okay, now I give you a few minutes to understand this question. Okay, to those already done with example 2, you may proceed with example 3. Okay, are you guys done with example 2? Kids, are you guys done?
Dan.
Done. Okay, the rest? Yang lain dah, betul?
Dah.
Okay, mari kita tengok example 3. Okay, so example 3, I think I need to show you. This is macam soalan favorite exam lah. Okay, figure above shows a mass 1 positioned between two masses M2 and 40 kg and M3 60 kg. M2 and M3 are separated by 15 meter. Okay, nampak tak? Jarak daripada M2 sampailah ke M3 is separated by 15 meter. M1 is placed at distance x from M2. Determine x when M1 will experience zero net gravitational force. What does it mean? It means dekat M1 ini, dia akan experience zero net gravitational force. Okay, what does it mean by net? Anyone? What does it mean by net? What is net? Total, very good. So dia adalah total. So apa yang kita nak buat sekarang adalah kita tengok dulu. Dekat M1 ini, gravitational force dia akan ada dua. Iaitu satu adalah by mass 1 on mass 2 and mass 3 and another one by mass 1 on mass 2. So kita ada dua, F13 and F12. And dia dah cakap dah, dekat mass 1, dia punya gravitational force is 0. Okay, dia sendiri dah cakap. Dia kata, determine x when M1 will experience zero net. Okay, total dia adalah 0. So, apa yang kita nak buat sekarang adalah kita ambil sahaja F13. Okay, cuba tengok. F13 is to the right. So, bila dia to the right, dia adalah positive. F12 dia to the left. So, bila dia to the left, dia adalah negative. Okay, awak kena faham tau. Jadi, nampak tak? Tengok direction ni. Okay, look at this direction. So, F13 is to the right. While F12 is to the left. Sebab itu, F13 is positive dan F12 is negative. So, sebenarnya dia adalah F13 net total tambah dengan F1 negative. Sorry. What is happening now? Okay, so tambah dengan negative F12 equals to 0. So, kita sambung lagi. Bila kita sambung dia, kita akan dapat F13 equals to F12. So, bila dia cakap experience zero net gravitational force, awak kena faham ini dulu. This is mean by zero net gravitational force. Dan sekarang dia akan ada dua gravitational force. Dia akan ada dua attraction. So bila dua attraction ni kita tambahkan dia equals to 0 dan awak akan dapat yang ini. Okay, so bila awak dah dapat ini, masukkan je dalam formula gravitational force iaitu G. Okay, I need to tutup ni kot. Sekejap ya. So masukkan je. So awak tahu G M1 M3 over R13 squared equals to G M1 M2 over R12 squared. Okay. So bila dah masuk dekat sini, apa yang awak boleh potong? Kita buat matematik sekarang. Apa yang sama? Apa yang awak boleh potong?
M1.
G dan juga M1. So bila awak potong G dan M1, awak akan tinggal dengan M3 mass 3 over distance from 1 to 3 equals to mass 2 over distance from 1 to 2 squared. Okay, sekarang kita tengok, kita tahu tak mass kita berapa? Mass ketiga kita dekat soalan dia dah bagi tahu dah 60 kg and mass 2 kita adalah 40 kg. So tulis dulu 60 over and then yang ini adalah 40 kg. Okay, but my question, distance from 1 to 3. Berapakah distance from 1 to 3? Anyone? Berapa distance?
Tolak X.
Sorry again, apa dia?
15 tolak X.
Very good. Dia adalah 15 tolak X. Kenapa 15 tolak X? Sebab kita tahu distance from 2 to 3 adalah 15 meter dan distance from 2 to 1 adalah x. Okay. So jadi kalau kita nak cari distance from 1 to 3, kita akan ambil 15 tolak dengan x. So kita tulislah dia adalah 15 tolak x. So here will be 15 minus x squared. Okay, dan dekat sini dia adalah x squared. Okay now, so now kita akan masuk matematik. The first thing that we are going to settle is 15 minus x squared. Jadi kita kena buka dia. So bila kita buka dia, kita akan dapat 15 tolak x darab dengan 15 tolak x. So apa yang awak akan buat, awak akan ambil 15 times 15 and 15 times negative x times 15 and negative x times negative x. Di mana awak akan dapat dia 225 minus 15x minus 15x plus x squared. So literally you akan dapat x squared minus 30x plus 225. Jadi masukkan dia balik. Okay, I'll continue here ya. So 60 over x squared minus 30x plus 225 equals to 40 minus x squared. And remember, kita nak cari x. Okay, kita nak cari x. So now from here, awak akan buat cross multiplication. So from cross multiplication ni, awak akan dapat 6x squared equals to, 60x squared equals to 40x squared minus 1200x plus 9,000. Okay. So ini korang buatlah. And then kita akan bawa all this equation ke belah kiri. So 60 tolak 40 awak akan dapat 20x squared plus 1200x minus 9,000 equals to 0. So from here masukkan dalam calculator quadratic equation. So this is quadratic equation. Masukkan dalam calculator. Quadratic equation di mana where your A is 20, your B is 1200 and your C is negative 9,000. So bila dah masuk dalam calculator, okay, cuba masukkan korang dapat berapa? Okay, everyone cuba masukkan korang dapat berapa sebenarnya? Okay, try masukkan dan beritahu kat Miss korang akan dapat X berapa?
6.72.
6.72. Okay, so it's around, I got 9.74 meter. So it's around 9.7 to 9.75 meter. Okay, boleh faham tak soalan dia macam mana? Okay, can you understand the question?
Yes.
Yes, the question actually quite easy, you know, but when it comes to mathematics, it's a bit hard. So you really need to brush up on your mathematics skills, alright? Okay, I give you a few minutes to see this question. And once you guys are done, tekan nombor 1 di chat box here. Okay, very good.
Miss,
Ya, saya.
nak tengok nombor 1 je boleh tak?
Nombor 1, example 1 ke?
Example 1.
Boleh. Okay, ni example 1 awak. Okay, nampak ke?
Nampak.
Okay, very good guys. Okay, this topic is very easy lah. I think like macam nak mengajar dia pun quite calm compared to other topics. Okay, very good. Okay, dan kau ada nombor 1, example 1?
Dan Miss, dan. Thank you Miss.
Alright. Okay, so ini adalah example 3. Okay, I think most of you already done with example 3. May I proceed?
Yes.
Okay, I'll proceed. Okay, actually this is my true handwriting tau sebab Miss guna drawing tablet, right? Okay, now we are going to look at another learning outcome which is defined and use gravitational field strength. So, awak kena define and use gravitational field strength. Alright, before kita proceed, gravitational field strength is a vector quantity or scalar quantity? Anyone? Scalar or vector quantity?
Scalar.
Gravitational field strength. Okay, tak apa. Miss bagi hint Okay. Yes, it is vector quantity. Okay. Kenapa dia vector quantity? Okay. Sebab gravitational field strength ini kan okay, juga dikenali sebagai, is also known as what? Also known as free fall acceleration, or also known as gravitational acceleration. Okay, dia dikenali sebagai ini. So, kalau Miss nak tanya, kalau dekat Earth, dekat surface of the Earth, dekat kita, bumi, permukaan bumi, berapakah gravitational acceleration kita? Siapa tahu? Siapa tahu? Simbol untuk gravitational acceleration ada dua, AG ataupun G. Siapa tahu? Berapa dekat Earth gravitational acceleration dia? 9.81. So dia ada dua, sama ada AG atau G. So usually untuk chapter ni Miss akan pakai AG tau. Okay, acceleration subscript G. Acceleration subscript G adalah gravitational acceleration. Okay. Now, dia cakap what is the definition of gravitational field strength ini? Dia kata gravitational field is a region. Okay, dia macam a region of space surrounding a body that has a property of mass. Okay, senang cerita, your body itu, your particle, your object must have mass. Kena ada jisim. Kalau tak ada, Batrisha, you okay Batrisha?
Okay, Miss.
Alright, okay now, kalau tak ada mass, kita tak boleh ada gravitational field. Okay, dia kena ada mass dulu. Di mana attractive force dia is experienced if a test mass placed in the region. Okay, kalau test mass tu placed in the region. Okay, apa maksud dia sebenarnya? Okay, sebelum itu, okay, maksud dia senang sahaja. Contohnya, this is Earth. Okay, Miss buat yang ni lah Earth. Okay, for example, this is Earth. Okay, and then you have a satellite, for example. You have a satellite. So, sebenarnya sekarang you punya satellite ini, dia berada dalam space surrounding a body that has a property of mass, yang mana dia akan ada attractive force. So, attractive force dia adalah contoh Earth to satellite, from Earth to satellite, dan juga from satellite to Earth. Okay, dia akan ada attractive force. Okay, attractive force ni antara test mass dan juga point mass. So this is like the region lah. So region itu macam yang Miss colour dengan warna ni. So this is the region. The region yang akan ada gravitational field strength. Alright, now, so you need to differentiate between test mass dan juga point mass. Okay, what is test mass? Okay, test mass dia akan moving. Okay, object tu moving. So maksudnya contohnya sekarang your satellite is test mass. Sebab apa? Sebab satellite dia akan orbit the Earth. Okay, satellite will orbit the Earth. So this is test mass. While this one is point mass. Dia akan stay. Okay, dia akan stay. Okay, now remember you need to differentiate between point mass and test mass. It is very, very important. Test mass and also point mass. Okay, first thing first adalah awak punya test mass, dia akan bergerak. It's going to move. Maksudnya contoh, you have an Earth and you have a satellite. Your satellite is orbiting the Earth. When satellite is orbiting the Earth, maksudnya your satellite is test mass while your Earth is point mass. Okay, now I have a question. Contoh, you have a moon and an Earth. Kita tahu moon akan orbit the Earth. Okay, now which one is test mass, which one is point mass? Okay, Miss. Ada yang nak jawab? Yang mana test mass, yang mana point mass?
Test mass moon.
Okay, test mass moon. Very good. Point mass akan jadi?
Earth.
Earth. Okay, very good. You guys got the idea. Okay, another one. We have sun and earth. Okay, kita ada matahari dan juga bumi. Yang mana test mass, yang mana point mass?
Test mass Earth, point mass Sun.
Very good. Sebab apa? Sebab earth mengelilingi matahari. So, matahari awak akan jadi point mass manakala your earth will become test mass. Okay, can? Okay, so far so good everyone?
Yes, Miss.
Okay, now. Okay, alright. Korang cari space yang tulis. Miss minta maaf, Miss bagi space yang kurang. Okay, now for example. Okay, kita tahu Newton's second law. Newton's second law is force equals to mass darab dengan acceleration. Okay, now so our force here we have gravitational force equals to mass darab dengan gravitational acceleration. Now our focus is on gravitational acceleration. So kalau kita susun balik equation ini, kita akan dapat gravitational acceleration equals to gravitational force over mass. Okay, so this is one of the equation you can use. Okay, Miss continue lagi. What is the formula for gravitational force? Okay, apakah formula gravitational force? Kita dah belajar tadi. Okay, apakah formula gravitational force? Anyone?
E darab mm over r squared.
Over r squared. Very good. So now look at here. So now you have gravitational force and gravitational force. What I'm going to do, this is your first equation and this is your second equation. I'm going to substitute your second equation into 2. Sub 2 into 1. So bila awak dah substitute, awak akan dapat GMM over r squared m, which we can cancel the m. So bila cancel the m, awak akan dapat your gravitational acceleration equals to gm over r squared. Okay, boleh? Okay, kejap Miss bagi masa salin ya. You guys dengar dulu. So literally our formula is gravitational acceleration equals to gm over r squared. Okay, what is the unit for gravitational acceleration? Acceleration. Apakah formula dia? Anyone?
ms negative 2.
Very good. ms negative 2 or another one is Newton per kg. But usually kita akan pakai yang inilah ms negative 2. Okay, now let's label. So kita punya AG adalah okay, AG kita adalah gravitational acceleration. No? Acceleration. Okay, so dia adalah gravitational acceleration. While our M is point mass. Capital M is point mass. If small m is test mass. Korang kena bezakan ya. While R, what's about your R? R adalah distance between test mass and point mass. R adalah distance between test mass and point mass. And point mass. Okay. And then, okay. So this is the inilah labeling dia. So awak kena bezakan tau. So kalau capital M ini, dia adalah point mass. Kalau small m ini, dia adalah test mass. Okay, boleh? Okay, kids, do you understand?
Yes.
Alright, okay now. So Miss bagi masa untuk korang salin. Once you guys are done and understand this part, do let me know ya. Okay.
Miss,
Yes, Alia?
macam AG sama dengan GM per R kuasa 2 tu, maknanya M tu tak semestinya sentiasa M besar lah kan?
Oh no, dia M besar. Memang sentiasa M besar. Sebab apa? Sebab Miss dah cancel M kecil. So kalau awak pakai formula ini, formula yang kejap mana macam ni Miss nak tulis Okay, where I am. Sekejap Miss kena keluar. So contoh kalau awak pakai formula ini, memang ini adalah point mass. Okay, dia selalu ini adalah awak punya point mass. Okay, boleh? So dia adalah point mass awak.
M kecil tu kan test mass kan? Yang tu.
Okay, M kecil kalau awak pakai formula ini.
Oh.
Ini kalau dia adalah test mass. Okay, but usually memang kita akan fokus yang ini saja. Okay, boleh?
Boleh Miss.
Okay, once you guys are done and understand this part, please press 1 dekat chat box. Okay, now can we proceed? May I proceed, guys?
Yes.
Yes, okay, Miss akan proceed ya. Okay, now sekarang macam kita cakap lah, fill line. So the fill line, okay, this is the fill line sebenarnya. Okay, all this is the fill line. So the arrow ni dia akan represent the direction of the fill lah. Direction of the fill. Manakala the spacing of the line, okay, the spacing of the line ni, dia akan represent strength of the fill. Okay, strength of the fill. Okay, for example, I have a question. Contoh, kalau spacing korang dekat-dekat macam ni kan, okay, look. So the spacing is near. What about the strength? The strength increase or decrease?
Increase.
Increase, very good. So you need to know if your spacing nearer, your strength of fill increase. Okay? Increase. Alright. So that's all. Nothing much about this one. Okay, now actually this is not in your syllabus anymore, but I want to focus on these two. Outside the earth and on the earth. What I want to focus is the gravitational acceleration. As you can see, okay, this is your earth. Okay, this is our earth, right? Okay, ini adalah bumi kita and we have an object. For example, the object is outside the earth. Okay, my question here, from here to here, ini distance apa? Ini adalah radius of what? From here, from the center to the here, ni radius apa? Anyone?
Earth.
Okay, very good. Dia adalah radius of earth. Okay, korang kena tahu tau, dia adalah radius of earth. Manakala from the surface of the earth until the object, dia adalah satu height. Okay, dia adalah height. Jadi kalau awak nak cari radius dia will always be from the center of the earth until the object. So itu adalah radius. Therefore, actually radius is from, not radius, distance. Ini ada distance ya. Ini adalah distance. Kalau awak nak cari distance dia adalah from center of the earth until the object. Therefore, dia punya distance adalah radius of earth tambah dengan height. And height ini adalah from the surface of the earth. From the surface of the earth sampailah object. So ini adalah R equals to radius of earth tambah dengan height. This is very very important. Ini sangat penting ya. If the object is outside the earth. Okay. If the object is on the earth, berada dekat atas surface of the earth, maksudnya kita lah manusia kan. So sebenarnya distance dia sama dengan radius of earth. Sebab ini kan R, jarak dia kan, distance dia. So distance dia sama dengan radius of earth if the object is on the surface of the earth. Okay, awak kena faham dua benda yang berbeza ini. Ini adalah distance juga. Tapi apa yang Miss nak korang faham is this one. Okay, boleh? And if on the earth, kita memang dah tahu dah gravitational acceleration dia adalah 9.81 meter per second squared. Sometimes diorang akan kata 10 lah, but usually we will take 9.81. Okay, boleh ke?
Boleh.
Okay, yang lain okay?
Okay.
Okay, Miss.
Okay, may I proceed?
Boleh.
Yes.
Okay, semua dah salin ya? Okay, so I'll proceed. Okay, now let's look at the graph. Okay, this is for your knowledge, okay? This is for your knowledge. Alright, now, if it's inside the earth, okay, kita akan ada dua graph. Graph yang pertama, bila dia inside the earth. Graph yang kedua, bila dia outside the earth. Okay, what I mean by inside the earth adalah, okay, so actually this graph tak betul tau. So korang kena sambung dia sampai hujung sini. So it's 0 here. Okay, so the one that I highlight with yellow, dia adalah inside the earth. The one that I highlight with orange, it is outside of the earth. So kita ada dua, inside and outside. Dekat sini, inside earth. Inside earth. Yang dekat sini adalah outside earth. Okay, for inside earth, gravitational acceleration dia ni, for inside earth, right? Okay, for inside earth, gravitational acceleration there is directly proportional to R, to your distance. If your distance increases, your gravitational acceleration also increases. As you can see, the distance dia increase, dia punya gravitational acceleration also increase. So nampak tak? From 0 to 10, dia akan increase. Meanwhile, for outside earth, dia punya gravitational acceleration is inversely proportional to the distance. If your distance increase, your gravitational acceleration decreases. So this is the case for outside earth and this one is for inside earth. Okay, so this is for your knowledge lah, Miss Aja, but nothing much. So distance from earth to center, unit dia adalah meter, wajib ya, dalam meter, SI unit. Meanwhile, the acceleration of gravity adalah ms negative 2. Okay, now, if you are done, you can try example 4. Miss bagi masa ya. Can we?
Boleh.
Alright, okay now, Miss proceed ya. Semua orang dah ke yang ini? Guys, dah ke?
Sudah.
Sudah ya? Okay, korang try buat example 4. Once you guys are done with example 4, tekan nombor 1 di chat box. Okay, if you guys are done, press number 1 ya. Miss bagi masa. It's okay, take your time. Okay, Mawada is done. Now can you hear me? Kids, boleh dengar Miss tak sekarang?
Yes,
Sekarang
Miss.
boleh.
Boleh.
Boleh. Oh, Miss cakap seorang lah tadi. Okay now guys, may I discuss?
Boleh.
Yes.
Okay now, sekarang kita nak cari determine the earth gravitational field strength. Okay. On the surface. Okay, on the surface. Okay, for example, on the surface maksudnya contohnya this is your earth and then dia nak kita cari on the surface lah, contohnya yang ini. So what we need to do now is kita tengok dulu dia punya distance from the center of the earth berapa? Berapa ke distance dia from center of earth? Anyone? Radius of earth berapa? Oh, Miss tak bagi Kids, radius of earth berapa? 6.4 times 10 to power of 6. Usually, dekat question dia akan bagi. If dia tak bagi dekat question, awak perlu tengok dekat list of constant. Okay, boleh? Guys, can you hear me?
Boleh, Miss.
Boleh. Okay, so this is the radius of Earth. Now we are going to find for the gravitational field strength. So kita tahu gravitational field strength, formula dia adalah Gm over R squared. Okay, now your G always constant iaitu 6.67 times 10 to power of negative 11. And your mass of Earth berapa? 6 times 10 to power of 24. And radius of Earth, sebab kita tahu distance dia adalah from center of the Earth to the surface of the Earth. So distance dia adalah sama dengan radius of Earth. 6.4 times 10 to power 6 squared. So therefore, awak tekan kalkulator, korang dapat berapa? Berapa korang dapat? Kids? 9.77 meter per second squared. Alright, boleh? Okay ke?
Boleh.
Okay, Miss.
Boleh. Okay, now determine the Earth gravitational field at an altitude of 350 kilometer. Okay, 350 kilometer. Okay, mari kita tengok macam mana nak buat dia. So for example, this is your Earth and then awak nak cari bila dia berada 350 kilometer. So ini adalah height dia iaitu 350 kilometer from the surface of the Earth. Okay, from the surface of the Earth to the center of the Earth adalah radius of Earth which is 6.4 times 10 to power 6 meter. Jadi, Miss nak tanya, distance from center of the Earth to the altitude ni berapa? Berapa R dia? Macam mana kita nak cari R dia, distance dia? Anyone?
Tambah.
Macam mana kita
Tambah.
tambah? Very good. So 350 kilometer. Change it to your SI unit which is meter tambah dengan 6.4 times 10 to power of 6 meter. So tekan calculator, you will get your radius berapa. Cuba tekan jap, Miss tak kira ini. Dapat berapa? Guys.
6750000.
Betul? Okay now, so when you already get your distance, masukkan je lah dalam formula ni. So gravitational acceleration equals to gravitational constants. Benda ni, kita suka into shape ni, kejap ya. Okay, gravitational constant darab dengan your mass darab dengan distance squared. So kita tahu gravitational constant always fixed 6.67 times 10 to the power of negative 11. Mass of Earth depends on the question ya. Divided by distance squared. So distance squared is 675,000 squared. So tekan calculator, you will get 8.78 meter per second squared. 8.78 meter per second square. Okay, boleh?
Boleh.
Alright, easy je kan? The question is very direct. Okay. Okay, after you are done with example 4, boleh try example 5 ya. Okay, Miss tunjuk example 4. So this is example 4. Alia okay Alia?
Okay, Miss.
Fatin Adrena? Fatin Adrena, are you okay?
Okay, Miss.
Hanani?
Okay, Miss.
Hanani? Santi?
Okay, Miss.
Sharuni?
Okay, Miss.
Lo?
Okay, Miss.
Yoel?
Okay, Miss.
Yusra? Okay, miss. Alright, so once you guys are done with example 4, you may proceed with example 5 here. Okay, now let's proceed to example 5. I'll give you around 5 minutes to try, then we can discuss. Okay, once you guys are done with example 9, example 5, please press 1 dekat chat ya. Okay guys, are you guys done? Okay, Sharini done, Lo done, Hanani done. I'll discuss at 3:50, okay? Okay, to those who are done, you may proceed with example 6 here. Okay, 3:50, let's discuss. Okay, dia cakap the gravitational field strength on the Earth's surface is 9.81 meter per second. Okay, of course, kalau dekat surface of Earth, dia punya gravitational of course will be 9.81 meter per second squared. Now, but the question asks us to calculate the gravitational field strength at a point C at distance 1.5 r, okay? So, for example, this is going to be your point C. And then the point C, the distance is 1.5 r from the Earth's surface. So, this is the Earth's surface. Where r is the radius of Earth. Okay, so r is radius of Earth. And then we know daripada center until the surface of the Earth, dia adalah radius of Earth. Jadi, kita punya R akan jadi R equals to radius of Earth tambah dengan 1.5 radius of Earth. Alright, in order for us to find for the gravitational field strength, awak kena pakai formula Gm over R squared, where G is always constant, 6.67 times 10 to the power of negative 11. Meanwhile, for the mass of Earth is 6 times 10 to the power of 24 divided by R squared. So, the distance squared. Okay, now before we find for the distance, kita cari dulu distance dia. So, radius of Earth tambah dengan 1.5 radius of Earth, awak akan dapat 2.5 radius of Earth. Jadi, 2.5 and kita tahu radius of Earth is 6.4 times 10 to the power of 6. Okay, tekan calculator. Korang dapat berapa ya? Miss tak kira ni. Korang dapat berapa guys? Radius, distance dia? Anyone, can you help me? Hello? Boleh dengar Miss tak? Guys? Dapat berapa guys?
6
Berapa kosong?
6 kali.
Okay, apa dia? Berapa jawapan dia?
1, 6. Lepas tu 0, 6 kali.
Okay, 6 kali. So, 1.6 times 10 to the power of 7 meter. Okay, boleh? 6 kali ke awak? Okay, 6 kali ya. Alright, so 1.6 times 10 to the power of 7. So, that's your distance. So, masukkan dalam dalam formula times 10 to the power of 7 squared. So, tekan calculator, you will get berapa? Sepatutnya korang dapat 1.56 meter per second squared. Okay, boleh? Okay, are you guys okay? Hari ni korang tak jawab Miss lah. Miss macam rasa macam shock sendiri. Okay, tired Okay, semua orang cuba tekan calculator. Dapat tak jawapan yang sama?
Dapat.
Okay, very good. Now, the question asks us to find for the weight of a rock of mass 2.5 kg at point C. Okay, apakah formula weight? Anyone? Weight equals to
mg.
mg. Very good. Now, mass of the weight is 2.5. What about the gravitational acceleration at point C? Berapa? Korang pakai apa?
1.56.
Very good, 1.56. So, tekan calculator, you will get 3.9 Newton. Okay, boleh? Okay, now for example 6, homework esok Miss check dengan korang. Boleh ke? That's your homework. So your homework for today hanyalah example 6. Can you try?
Boleh.
Boleh, Miss.
Alright. Okay guys, I'll stop until here if you don't have any question. That's all from me. Thank you everyone. I'll send you the exit ticket. Tapi lambat sikit tau sebab Miss nak kena fix my laptop first. Can?
Boleh.
Okay. Boleh.
Okay, bye everyone. Assalamualaikum. Have a good day.
Thank you, Miss.
Miss.
Salam.
Thank you, Miss.